Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 6 on the elements in the periodic table, and we are going to be studying 6.2 properties of groups and elements today. So there are millions and millions of different kinds of matter, and all of these mixtures and compounds are composed of the same 92 naturally occurring elements. And all of these elements, plus all the other ones adding up to 118 that are synthesized, are organized into the periodic table. Why is it called periodic? Well, because there are repeating patterns. So elements that belong to the same column have similar chemical properties. So the properties of the alkali metals, which are, except for hydrogen, which is weird, are soft solids that are very reactive. That's going to repeat every time we get to group 1. Okay, so let's look at that. First up is group 1 alkali metals, so please write that down. They have one valence electron. And so if you have one valence electron, you want to get rid of that because you want to have 8. And you're really close to 8. If you get rid of 1, then you go down to the next shell, and that one would have a full shell of 8. So you want to get rid of 1 electron. If you get rid of 1 negativity, then you have more protons than electrons, so you have a +1 charge. They are extremely reactive. They really want to get rid of that 1 valence electron. Also, they are soft, shiny metals that react violently with water. And they readily form compounds. They readily form oxides with oxygen in a 2-to-1 ratio. So like Li2O and Na2O. And they form salts with halogens, and the halogens are like chlorine, bromine, iodine, that one in the second to last column, in a 1-to-1 ratio, like NaCl. So hydrogen acts differently than the others. It is a non-metal, it is a combustible gas, and it is a diatomic gas. So it's so reactive it will react with itself, and so it's always diatomic if it is just hydrogen. So hydrogen is the most abundant element in the universe. It makes up water, which is very abundant on Earth. Also, it is important for nuclear fusion, which occurs in the core of all stars. So it is happening in our sun, in our star, and that is what allows the Earth and life to be here, is all the energy given off from the nuclear fusion in our sun. Also, all acids have hydrogen in them, so it's important for acids in chemistry. Going down, lithium is an alkali metal, Li. It's used in batteries, ceramics, glass, antidepressants have lithium. Well, lithium is an antidepressant. Not all antidepressants have lithium in them. The next two going down, sodium, then potassium, have very important biological functions. If you've taken human biology, you know about sodium-potassium pumps are needed to send nerve impulses throughout the body. Also, sodium is in table salt, sodium chloride, and potassium is used in fertilizers and in industry. So you have potassium in a lot in your body, adenosine triphosphate, ATP, and then also in proteins and nucleic acids. And so it's important for all living things. Question for you guys is, why do elements in group 1 have the tendency to form +1 ions? Well, if we look here, alkali metals have a single electron in the highest unfilled energy level. We know that elements really want to have 8 valence electrons, 8 electrons in their outer shell. So if you see, if sodium got rid of this 1 electron in its third shell, its second shell would be the outer one then, and it would have 8, and it would be super happy. And potassium, if it could get rid of that 1 valence electron in its fourth shell, it would have 8 valence electrons in its third shell, which would then be the outer shell, and it would be super happy. So this one electron, when you get rid of that, when you get rid of one negativity, then you have more protons than electrons and you have a +1 charge, and that is why alkali metals form +1 ions. They also form in a 2-to-1 ratio with oxygen. So again, hydrogen isn't a metal, but it is in that same group, and we know H2O, it forms in a 2-to-1 ratio with oxygen. Lithium will form 2-to-1, sodium 2-to-1, potassium 2-to-1, because oxygen wants 2 electrons, so this lithium will give it 1 and this lithium will give it 1, and then everybody's happy. And then they form 1-to-1 ratios with the halogens, chlorine being an example, lithium chloride, sodium chloride, and potassium chloride. And again, chlorine has 7 and it really wants 1 more, and so these metals are more than happy to donate 1, and then everybody is happy. As I said, the alkali metals are very reactive and react violently with water. Here, this man is putting potassium in water. So again, the alkali metals are very reactive. Let's move to the next column with the alkaline earth metals, and that is group 2. Alkaline earth metals, group 2. So they're going to have 2 valence electrons, and they're going to form 2+ or +2 ions. They are very reactive, not quite as much as the alkali metals, but still quite reactive. They also readily form compounds. They form oxides with oxygen now in a 1-to-1 ratio, and they form salts with halogens in a 1-to-2 ratio. So starting at the top, beryllium, Be, is used in alloys for lightweight metal structures. So it's important if you want things to be lightweight. And then moving down, calcium, you should have heard of, and magnesium are very important in biological functions. Calcium, we know, is needed for bones, and if you've taken human biology, you also know it is needed for muscle contractions. Magnesium is needed for DNA, RNA, ATP. So from biology, you know the importance of those. All living beings have that. And also magnesium is important in industry, has a lot of different uses. So question is, why does this group form +2 ions? We didn't talk about strontium, barium, and radium. These are more common, but they are also group 2 ions. So they have 2 electrons in their outer shell. So if beryllium got rid of these 2 outer electrons, it would just have 2 in that first shell, and we know that first shell, 2 is a full outer shell, and so it would be happy and stable. And calcium has 2 in its 4th electron shell, so if it got rid of these 2, it would just have 3 in it. It would have 8 in its 3rd outer shell, which would then be its outer shell, and it would be happy. So beryllium, magnesium, calcium, they are going to form 1-to-1 ratios with oxygen. These want to get rid of 2 electrons, and oxygen wants to gain 2 electrons, so it's a match made in science. And then they form in a 1-to-2 ratio with halogens, for example, chlorine. So beryllium has 2, it'll donate 1 here, and it'll donate 1 here, and we know chlorine really wants to get 1 more electron. Those are the S block elements in group 1 and 2, group 1 alkali metals, group 2 alkaline earth metals. In our next video, we're going to talk about transition metals. All right, I'll see you then. Bye.